So the next question, consider a stable LTI system, that is linear time invariant system, that is characterized by a differential equation d squared y of t by dt squared plus 4 into dy of t by dt plus 3 into y of t, which is equal to d into x of t by dt plus 2 into x of t. Okay, or the same question can be asked as, find the impulse response, frequency response and output response for the input e power minus t u of t using Fourier analysis. Okay, so they have given this value differential equation and they are asked to find the impulse response, frequency response using Fourier analysis. So why they are taking Fourier analysis means they have asked to find the frequency response. Okay, so in order to find frequency response, you want to take the Fourier analysis. Okay, so Fourier analysis means in the place of S, we are transferring to j omega. Okay, this domain that is in time Laplace transform, time domain is changing to the space domain. Here time domain is changing to the frequency domain. Okay, so first they have asked to find the value of impulse response. Okay, in order to find impulse response, first you need the value of h of j omega, because here we are analyzing using Fourier analysis. Okay, so they've asked to find the frequency response also. So if you know h of j omega means, easily you can find the impulse response h of t. Okay, so first write given transfer function. What is the transfer function they have given? D squared y of t plus divided by dt squared plus 4 into dy of t by dt plus 3 y of t, which is equal to dx of t by dt plus 2 into x of t. Okay, so now take that differential equation. So in Laplace transform, we will replace d by dt as s, correct? Okay, so here in the place of s, you want to write j omega. So in d by dt, you want to write as j omega, and y of t as y of j omega, and x of t as x of j omega. Okay, in Fourier transform, in the place of d by dt, you want to write as j omega, and in the place of y of t, you want to write as y of j omega, and x of t as x of j omega. So here in the question, see, so d squared by dt squared. In Laplace transform, we will write d squared by dt squared as s squared. So here you want to write as j omega squared. Okay, j omega squared, and y of t can be represented as y of j omega plus 4 into d by dt can be written as j omega, and y of t as y of j omega plus 3 into y of j omega, which is equal to d by dt is again j omega, x of t is x of j omega plus 2 into x of j omega. Okay, so from this term, take y of j omega as common. Okay, so take outside, so remaining term j omega squared plus 4 j omega plus 3. So here take x of j omega, because we need h of j omega. What is h of j omega? Output by input, that is y of j omega by x of j omega. So you got j omega plus 2 divided by, okay, divided by j omega the whole square plus 4j omega plus 3. Okay, so now if you factorize this term, because it is also in the form s squared plus 4s plus 3, so you can easily factorize. Okay, so if you factorize this term, you got j omega plus 1 into j omega plus 3. So in order to find h of t, you want to apply the partial fraction. So a by j omega plus 1 plus b by j omega plus 3. So same method, only in the place of s you want to replace j omega. So now a is h of j omega into j omega plus 1. In the place of j omega substitute minus 1. Okay. So after substituting the value, we got a as 1 by 2. In b also, after substituting, we got b value as 1 by applying partial fraction. We got 1 by 2, a as 1 by 2 and b also 1 by 2. Okay. So it is h of j omega. So now we want to apply inverse. Here you want to analyze using Fourier transform. Okay, analyzing using Fourier transform. So here you want to apply inverse Fourier transform. So inverse Fourier transform of 1 by 2 j omega plus 1 is e power minus t. Here e power minus 3. The same formula as that of in Laplace transform. Okay, so our frequency response is h of j omega. We have find that. So right. So first they have asked to find impulse response h of t. Next they have asked to find frequency response h of j omega. So we have find two parameters. In the next step you want to find the value of output response. Okay. So in order to find output response, what is output response? Y of t. So in order to find y of t, you want to first find y of j omega. Okay, so find y of j omega. So for that, first write the transfer function value. Next, given input is x of t is e power minus t of t. If you take the Fourier transform, inverse Fourier transform, you got x of j omega is 1 by j omega plus 1. Okay, so now we need the output response y of t. So first you want to find y of j omega. So y of j omega is h of j omega into x of j omega. What is h of j omega? The given, we have find the frequency response as j omega plus 2 divided by j omega plus 1 into j omega plus 3 into 1 by j omega plus 1. So now write that value, and the denominator you got j omega plus 1 the whole squared into j omega plus 3. So now if you apply the partial fraction, what did you got? That is, you want to apply the partial fraction. So here the denominator is in the form j omega plus 1 the whole square. In simple method means we can easily apply a by first term, second term, third term, b by second term, c by third term. So here if you apply the partial fraction, what did you got? A by j omega plus 1 plus b by j omega plus 3 and c, sorry, a by j omega plus 3, b by j omega plus 1 and c by j omega plus 1 the whole square. Okay, so by applying this you want to find the value of a, b and c. Okay. So listen, in partial fraction, so in order to find this b and c, you want to find a new frequency response, new output response, that is y1 of g. Okay, normally in partial fraction, we will find the value, that is you want to find another value, because if you apply this value, you can't you can't apply the partial fraction. Okay, so you want to find a new output response value, that is y1 of j omega is equal to y of j omega into this j omega plus 1 the whole squared. Okay, so now this two value get cancelled and you got y1 of j omega as this term. So in order to find b and c, you want to apply this y1 of j omega, but while finding a, you can apply this y of j omega. Remember that in order to find a, you can apply y of j omega, and in order to find b and c, you want to apply only y1 of j omega. Okay, so now you can find the value. So in order to find the value, here a is y of j omega into j omega plus 3, and you can get the value as a is equal to minus 1 by 4. In order to find b, I said you want to apply y1 of j omega. So what is the formula? 1 by the degree value, 2 minus 1 factorial, sorry, not the highest order term is 2. Okay, highest degree is 2. So 2 minus. So here in b, the denominator value is, what is the denominator value? In b, you got j omega plus 1. So here the degree is 1. So 2 minus 1 factorial, d per same thing, n minus 1 and d of j omega n minus 1, y1 of j omega divided by, in the place of j omega, I want to substitute minus 1. So substitute all the value. After substituting, got b is equal to 1 by 4. And next also, in order to find c, same method. So here the degree is in c, what is the value? J omega plus 1 the whole square. So this term will become here, okay, 2 minus 2 factorial. Similarly here also. So 1 by 0 factorial is 1. D per 0 by d j omega per, so this term become 1. So only apply j of omega in the place of j omega and substitute minus 1. So you got the value c. Okay, so now you got a, b and c value. So what is a? Minus 1 by 4. B also 1 by 4. C is 1 by 4. So apply the formula. So Laplace transform of, that is inverse value. If you apply Fourier transform, you got e power minus 3t, here e power minus t, and here what is the value? You know the Laplace transform of 1 by s plus a the whole, and here j omega. In the place of s, you can put for j omega. Whole power n is t power n minus 1 divided by n minus 1 the factorial e power minus at. Okay, because all are transforming to t domain only. So the formulas are somewhat Same. So here what is the value? T power n minus 1. So 2 minus 1 is 1 divided by 2 minus 1 factorial 1 factorial e power minus. Here a value is, what is a value? 1 t. Okay, so you got the answer. Y of t output response is minus 1 by 4 e power minus 3 t plus 1 by 4 e power minus t plus 1 by 2 t into e power minus t. Okay, so in the question they have asked to find the value. What are the parameters they have asked to find? They have asked to find the value impulse response, that is h of t, then frequency response, that is h of j omega, and output response, that is y of t. Okay, so and they have given the input as x of t is equal to e power minus t u of t. So here they have asked to find using Fourier, so only we are replacing all s value to j omega. Can you understand? Okay, so remember, always remember, impulse response means you want to find the value h of t, output means y of t. So in order to find y of t, from h of s you can find y of s, and next you can find y of t. Okay, so frequency response means h of j omega. So for this you want to take the Fourier analysis. Okay.